to get that. Okay. So we were talking about glomerular filtration and urine formation. The first part of urine formation is filtration, and that's what happens in here. The glomerulus, between the glomerulus and the glomerular capsule, right? So basically, all of the fluids and substances that are traveling in this glomerulus are going to be filtered out into the capsule. And then we begin a process of reabsorption and secretion. And in reality, a lot of the stuff that's filtered here is going to be reabsorbed again. And I went back to this picture because I want you to realize that reabsorption means taking it from the tubule where it would have been urine or waste and putting it back into the bloodstream. And then secretion is taking it from the blood vessels to the tubule. So it is going to be waste products. And that's basically what happens. You take everything out as filtrate into the tubule, and then you put most of it back into the bloodstream because it's stuff that we need. And then we fine tune with secretion and maybe reabsorption of smaller amounts of things. So this happens throughout the different parts of the tubule, and different things happen in different parts. So you have certain things that happen in the proximal convoluted tubule, things that happen in the loop, things that happen in the distal, and then in the collecting duct. But I wanted to revisit that before we talk about glomerular filtration. So this is the part where you have a glomerulus and you have a glomerular capsule, and in between the visceral and parietal layers of that capsule is a space called the glomerular or capsular space, and that is where that filtrate goes. So there are forces that determine the rate of this filtration. So glomerular filtration rate, this is an important definition that you should know. It is the amount of filtrate. Remember, filtrate is everything that was taken out of the capillaries and filtered into that space. That is all filtrate. So the amount of filtrate formed by both kidneys per minute is your glomerular filtration rate. You'll see it referred to as GFR. And the glomerular filtration rate is important because it's a measurement that we use to tell us how well the kidneys are doing what they're supposed to do. Thank you. If it wasn't for that finger, I would never let these people in. Another? Oh, okay. So we do like to refer to the glomerular filtration rate quite often because it's a good indication of how much blood is coming in here, how much are we filtering out, are we able to get as much as we need to. So obviously homeostasis is the big thing, right? Everything our body does is to achieve homeostasis. Getting annoying. Okay. Right. In order for the kidneys to help with homeostasis, that glomerular filtration rate needs to remain constant or as stable as possible. It can't be too high, can't be too low. If it is too high, if my glomerular filtration rate is too high, meaning the blood that's coming through there that's being filtered, that filtrate is passing too quickly. If it's too high, you end up not absorbing what you should absorb, okay? This is sort of like you are at the airport on the conveyor belt and you're waiting to pick up your bags, but then all of a sudden it goes in super speed. If that belt is moving too fast, you don't have a chance to grab the things that you need, right? And that's what happens if your glomerular filtration rate is too high, filtrate is passing through too quickly, you don't get a chance to reabsorb into the bloodstream all of the nutrients and water and glucose and things that you need to put into your bloodstream. If it's too low, you end up reabsorbing more than you need, right? And you end up with waste products that you didn't want. And this kind of reminds me of, like, we don't have any here, but there are restaurants that are all you can eat restaurants. But instead of you getting up and going to where the food is, you sit down like at a bar and the food passes through on a little belt. So, and really you could use that for the first example too. But if this food is passing by really slow, right? And you're sitting there and you see chocolate cake, you're like, yeah, no, I didn't want chocolate cake. But then half a minute later and the chocolate cake is just barely making it to you. Well, maybe I do want chocolate cake. Okay, I'll take chocolate cake. And then behind that is a brownie. Well, maybe I want that too. Okay, I'll take that too. So you end up taking way more than you actually need. And that's what happens when the glomerular filtration rate is too slow. A lot of stuff is going to be reabsorbed. So much stuff, in fact, that you'll end up with waste products that you didn't want to reabsorb, taken and reabsorbed back into the bloodstream. Okay? There's that smile. That restaurant idea is a really good idea, isn't it? We should have one. Somebody should open that. What? Yeah? Did they used to do that? On the beach? Oh, yeah. So one of my favorite restaurants is Fogo de Chao, and we don't have one here, but they have one in Orlando. My favorite one is the one in Atlanta. Yes, that is, I'm not even a meat eater, but when I go, it's a Brazilian steakhouse where they bring the meats to you and slice it in front of you. When I go, I become like a monstrous carnivore. I will eat and eat and eat and eat. And I'm like, salad? No, I don't want salad, and salad is really one of my favorite foods. But yeah. So anyways, this is what happens if you have an imbalance in this rate, and you really do, you want the kidneys to be able to keep it as stable and constant as possible so that you just reabsorb what you need and you have time to put back or secrete the waste products that you don't need. So let's talk about the factors that, I could use this. The factors that determine this glomerular filtration rate. So we have 3 different pressures in different directions that can influence this rate. And the first one, number 1, right here, is the blood pressure. So what is the pressure of blood in this glomerulus? Okay? That is going to exert a force outward, meaning if pressure is high in this glomerulus, it is going to help force things through that filtration membrane and into the space. So you're actually producing, it's helping produce filtrate, okay? So your first factor is glomerular blood pressure, and that is the pressure in those capillaries. There are 2 other forces that work in the opposite direction, and one of them is, for number 2, is the capsular hydrostatic pressure, meaning the pressure here in this space. So if I already have a capsular space that is filled with fluid, that is going to exert pressure against filtration. Make sense? Yes? Okay. Our third force is going to be the blood colloidal osmotic pressure, and that is actually due to the plasma proteins that we have in our blood. So if we have a high osmotic pressure in blood, meaning there's a lot of plasma proteins, that works against filtration. Okay, why? Because we already learned in AMP1 that naturally things want to equalize osmotic pressure, right? If you have a high osmotic pressure on one side of the membrane with lower osmotic pressure on the other side, it is going to want to put that fluid onto that other side to equalize the pressure of both sides. So those are the 3 factors that influence this initial glomerular filtration rate. Pressure in the capillaries, which is going to promote filtration, pressure in the capsule, which will work against filtration, and then osmotic pressure due to the plasma proteins in blood, which will also work against filtration. So the net filtration rate is going to be all of those added together, whether they're a positive or a negative. Any questions on this one? No? Okay. Let me move this camera a little bit. Okay, so we know the kidneys have to keep a stable glomerular filtration rate. We know what determines glomerular filtration rate, what affects it. How does the kidney, or how does our body keep a stable glomerular filtration rate? First of all, let's learn our standards. So average in males is 125 milliliters per minute. In females, it is 105 milliliters per minute. That means that at any given minute, I can measure a male's glomerular filtration rate, and I should get 125 milliliters of filtrate. Okay? So, what controls it? We have renal autoregulation. This happens within the kidney, and it's a way that the kidney can control its own filtration rate. We also have neural regulation, and that is all done by the autonomic nervous system. And then we have hormonal regulation, and those hormones are coming from outside of the kidney, but they will influence that glomerular filtration rate. So let's talk about the renal autoregulation. Two types of autoregulation for GFR in the kidneys. Myogenic, the word myo comes from muscle. So the myogenic autoregulation says that when blood flow pressure is increased in that afferent arteriole, that's going to stretch the walls of those capillaries. When they stretch out, the smooth muscle in those capillaries will actually contract and make the diameter of the capillaries smaller. Okay? So we have an afferent arteriole that looks like this. If the pressure increases in here, then the walls, the muscle in those walls will contract and make it a smaller diameter. How does that help? Well, if you have a big hose that's like 2 inches in diameter and you put high pressure water through it, you're going to get a lot of water. If I have that same pressure, but I make that diameter smaller, if I use a straw instead, I'm going to get much less water out of it, right? And that's how that myogenic autoregulation works. It's just a matter of decreasing the diameter, making that arteriole smaller so less blood can get through it, okay? Notice the pressure is still there, but it's less amount of blood that's coming through. And then we have the tubuloglomerular feedback, and this is the one where we're going to refer back to the juxtaglomerular apparatus. Do you guys remember that? Remember where you had the afferent arteriole in one part will actually touch a piece of the tubule, right? And that part of the tubule was called the macula, and it had cells all lined up really close to each other, and those cells had the special ability of detecting the pressure of the blood flowing through that afferent arteriole. And when that pressure was elevated, those cells were able to release a substance that allows relaxation of the other arterioles so that the pressure goes down, okay? If that's too confusing, please remember that the tubuloglomerular feedback is through the juxtaglomerular apparatus. So I have two ways to autoregulate within the kidney. One of them is going to make the diameter of this arteriole smaller. The other one is going to help reduce the pressure. Okay. Our hormonal regulation, and we're going to talk about hormones probably at the end of the week. We'll get to the specifics of these hormones, but we're only going to talk about two real quick right now. Angiotensin 2 is a hormone that's released by hepatocytes in the liver as angiotensin 1, and then it is converted into angiotensin 2, which is the active form. What does it do? It's going to vasoconstrict. When it vasoconstricts, again, you're doing this. You are decreasing the diameter, and that's going to decrease our glomerular filtration rate. Okay? We have AMP, or atrial natriuretic peptide. You'll see it referred to as AMP. This comes from the heart. So when the heart releases atrial natriuretic peptide, or AMP, it's going to go to the kidney, cause vasodilation, and increasing your glomerular filtration rate. You're vasodilating, you're putting in more blood to the kidney. When you give it more blood, it has more to filter, so you increase that glomerular filtration rate. Are we okay with the glomerular filtration rate? We're not asking any questions today, are we? Okay. Yes, Erica, you have something on the tip of your tongue. Oh, sorry. Sorry. Okay, and here it is in table form. If you guys want to go back and read it, you can. We really talked about the main parts of it. There's your hormonal regulation. Now let's talk about reabsorption and secretion. So we learned about filtrate, the glomerular filtration rate, and the things that influence it and regulate it. Let's talk about what happens after that filtrate is in the tubule. As it's traveling through the proximal the loop and the distal convoluted tubule, what's happening to it. So we have two things that can happen. It's either reabsorption or secretion. Reabsorption. I already told you that most of the stuff that filters through that filtration membrane will actually be reabsorbed into the bloodstream. It is stuff that we need. Things like water, glucose, amino acids, and ions. And then we are going to also secrete anything that we don't need. So we're going to secrete any of the waste products that may happen to be reabsorbed by accident. We'll also use secretion to balance our pH, and that's going to be something that we'll do at the end of the tubules, because it is really important to have your blood balance as far as pH is going. Okay, so two modes for reabsorption. So how do I take the stuff from the tubule and put it into the blood vessel that's laying next to the tubule? Two ways we can do it. It can either seep or leak in between the cells, like this sodium is doing right here. And these are tubular cells, by the way. Or I can actively transport it into the cell and then push it out of the cell, and then it will go into the blood vessel like we did right here. So here you are actively pushing it into and out. So if it's passively leaking in between the cells, that is paracellular reabsorption. So imagine you have two cells of a tubule, of the wall of the tubule, and in between them, there's a little bit of space, and that space allows for leakage of substances out of the tubule, and then that substance can be absorbed into the bloodstream. Or if it's active, it can be transcellular reabsorption. So that is when the substance goes into the cell, and then the cell uses ATP to push it out. That's what's happening here. Remember, this is an active transport. Transcellular requires some type of active transport, whereas paracellular, in between the cells, it's a passive mechanism. It just simply leaks out. Y'all put me to sleep. Any questions on this? Okay. The next few slides are a list of all of the things that are filtered, reabsorbed, and secreted. And you can take a look at that if you want. We're going to talk about the idea that water, you've got 180 liters coming through that capsule being filtered, but you also have almost the same amount being returned to your blood. Okay. Okay, so specifically, which part of the tube does what? And this is what you need to know. The proximal convoluted tubule, that's that very first part just after the glomerulus. Wake you guys up with some red. What happens there? Well, that's where most of my reabsorption happens, right? That's the first part, right after you get all that filtrate, put it all back in. So reabsorption happens mainly in the proximal convoluted tubule. The loop of Henle is where we are going to reabsorb cations, sodium, potassium, calcium. Your distal convoluted tubule after the loop is where you are going to get reabsorption of calcium, okay, depending on how much calcium you need. And then by the time you get to the collecting duct, after the distal convoluted tubule, you're in the collecting duct. By the time you get to the collecting duct, you pretty much have urine in the collecting duct, and then you're just fine-tuning pH. So you're really moving hydrogen ions around in order to fine-tune that pH. So collecting duct is where we secrete, or where the kidneys will secrete those hydrogen ions in order to adjust the pH. So you end up with an acidic urine, and you've got a pretty neutral blood. Any questions on reabsorption and secretion? All right. There we go. The following slides are also summaries that you can look at if you want to. It just talks about the different types of epithelium. Not a big deal. And then our hormonal regulation of secretion and reabsorption. All right. So that finishes up the urinary. I'm assuming we have no questions because no one has stopped me. Yes.
So you said in the collecting duct, the secretion of Are you supposed to do the balancing by turning out with blood and stuff like that? Okay.
Yes. And we're going to talk more about balancing that pH in the next slideshow, which is our acid-base balance. So, man, if I was on Zoom, I'd be asleep by now. Really all put me to sleep. Okay, so this is going to be our last PowerPoint for the unit. Almost there, woohoo. Anybody doing anything fun this weekend? Y'all ever do anything fun? Oh, see, I hear the word trampoline, I immediately think disc disease. Okay. I'm gonna keep using red because y'all are falling asleep and you put me to sleep. All right, fluids, electrolytes, and acid base balance. Let's talk about it. And this is actually, to me, it's kind of cool because what is it? What is what coming from? Oh, is it not published? It's in another unit. No, wait, go down after urinary. Right there.
So we're not doing this?
We finished that, didn't we? Are you serious? We didn't finish the second urinary lecture? Sorry. Well, thank you for noticing. I didn't even notice. I didn't know that. I'm sorry. Sorry. Thank you for speaking up. Nobody else said anything. They're all like, okay, here we go. Okay, so I completely skipped over that PowerPoint. Okay, sorry. I thought we were on to. Okay. Oh, I pulled up acid base. So this is not the last PowerPoint. Sorry. Jeez. Okay. Good call. Yeah, I did. Sorry. All right. Okay. Woo, urine production. Okay, so let's talk about urine. I totally skipped the whole thing. This is how I feel today. Now you know. All right, so it says fluid intake is highly variable. Yes, that's true. The amount of fluid you take can differ. You may be taking in a lot, a little bit, who knows. Point is, your kidneys are going to take everything that you take in and make and put all of your body fluids in balance, okay, regardless of what you've taken in. So that's the kidney's job, is to maintain your fluid volumes. That's one of its jobs. There is a hormone called antidiuretic hormone, and that is our most influential hormone when it comes to urine. We are going to talk about it again in a little bit. So if you take in a lot of fluids, say I'm drinking water all day long, right? I'm drinking so much water that I'm getting in way more than my body needs. Well, all of that excess water is going to be released from my body in the form of urine, but that will give me a high volume and very dilute urine, right? Let's say I don't drink enough water. I'm dehydrated. I'm not taking in enough water or eating anything that has enough water in it. So my body is needing more water. Well, what's going to end up is I have less excess to put as a waste product. So my urine is going to be super concentrated and dark and of less volume, okay? Very easy concept. If you have a lot of water coming in, you can release a lot of water as waste product. If you don't have enough coming in, you're going to have super concentrated urine in very little amounts, okay? Basic concepts here. Okay, so we use urine to measure the health of the kidneys, and that is called a urinalysis. This is what we did in lab. A urinalysis is the study of urine volume, physical properties, chemical composition, and microscopic properties. So whenever you take a sample of urine and you examine it for physical properties, chemical properties, it's microscopic, that is a urinalysis. And we use that to measure kidney function. We look for things like albumin, which is a protein in your blood that should not be in urine. Glucose, which is the sugar that your cells use that should not be in urine. Red blood cells should not be there. Ketone bodies, microbes, all of these are things that are abnormal findings we don't want to find in a urine sample, because those are all things that should not be there or should not leave the bloodstream. Are you okay? You're sleepy. All right. Oh, I'm sorry. Sorry. So I do want you to know the definition of a urinalysis, please. Okay. So we know that the glomerulus is going to do that initial filtrate, then the tubules will all reabsorb and secrete until at the end, collecting duct, we should now have urine. Well, what happens after that? Okay, after our collecting ducts, that urine is going to go to the renal pelvis, and then from the pelvis, it's going to go on to the ureter. I'm actually surprised at how many people don't know the difference between a ureter and a urethra. We have two ureters, one coming from each kidney. The ureter is going to take that urine to the bladder. I don't even see it here. Oh, okay. It's going to take it to the bladder. Now, the thing is, once the urine leaves the renal pelvis through the ureter and it goes down to the bladder, there's no check valves here. There's nothing controlling it. It simply just drips down like a continuous leaky faucet into the bladder, right? Which takes me back to, remember we were talking about the adipose capsule around the kidney, and I told you that there's instances where someone could have an eating disorder or lose weight too quickly, and that adipose capsule will deteriorate because it's being burnt up for energy, and then the kidneys will drop. We call that ptosis. That's when this becomes a problem, because the kidneys, if they're not held up in place, gravity can't work its way and drain into the bladder, right? Okay. So it gets to the bladder, then what happens? Well, it slowly drips into the bladder until the bladder begins to fill up. When the bladder begins to fill up, it's going to expand. That's going to cause pressure on the walls. That pressure on the walls is going to initiate a reflex that is going to relax that internal sphincter of the bladder and also initiate or give you the urge to go find a bathroom so you can relax the external sphincter of the bladder. Okay. Look at the capacity of the bladder is 700 to 800 milliliters. How much is that? How many milliliters are in a liter? 1,000. Yes, from the sleepy man in the back. I mean, the man in pain in the back. 1,000. And there's about 4 cups in a liter. So basically, our bladder can hold about 3 to 3.5 cups of liquid, and then it has to be evacuated. I know that doesn't seem like a lot, does it? I'm pretty sure that I've seen people really way more than that. But it is important to know the average, because if you're working in a hospital and you have a patient that's on a catheter, they always have a bag of urine that has measurements on it, right? And it's a good idea to kind of understand whether this patient is producing enough urine or not. That's one of the things that we have to monitor for, especially if you're in there. You know, I don't know if CNAs do it, but I know nurses will have to take note of how much urine output. You have to document it, right? But that's why you have to document it, because we use that to measure health of kidneys, or because kidneys do like to shut down, believe it or not. Ooh, fun. Okay. So this is the gross anatomy of the kidney. It is a hollow muscular organ in the pelvis. Notice that it does have rugae also, kind of just like the stomach in a way. It has the bladder. Did I say kidney? I meant the bladder. You know what I mean? I knew exactly what you meant. It says bladder. It's not my day, y'all. I'm telling you, I need it to be Friday already. Okay, so here you, woo, you got two ureters draining into this bladder here, this space. It is very muscular. It also has some really cool epithelium that we talked about in AP1. Do y'all remember what the epithelium is? Yes, it starts with a T. Transitional, that's right, transitional. Good job. So as it drips in here and this begins to fill up, eventually filling that up is going to stretch those walls. Stretching those walls is not only going to close off these openings here, and it does that so that you don't have urine go backflow, but it will also stimulate this internal sphincter here. So that internal sphincter is going to release, and then it's going to come down over in front of the external sphincter. Where's the external sphincter? Labeled on this picture. Oh, here it is. It is labeled. So why do you have to pee more? Right. So when you're pregnant, you have a weight that is bearing down here. So the capacity of the bladder is decreased. There's no room for it. So the minute it starts filling, you immediately start feeling that pressure, right? Because the space, it has no space to expand. So it fills, that stretches these walls, closes those openings, and then opens that internal sphincter. It goes down here. That's where you can voluntarily hold it until you can voluntarily release your external sphincter. Okay? And that is something that is developed as a child. This is why you have to go through potty training with your kids, and it does take time because this is a muscle that has to be trained. You do have to train a person to be able to voluntarily control it. Okay. So okay, so Erica is talking about catheters. When you have, and a catheter is when you come in with a little plastic straw tube type of thing, insert it in here, and then it allows all of the urine to drain to this external bag. And now you are, I just want them to hear it. So you're asking about training a bladder by cutting off or plugging temporarily this catheter, right? Okay. So we know that when we take over things for our body likes to ignore it and forget about it, right? Like you give yourself external hormones, we're going to stop producing our own. This is one of those things. You put a catheter in here, you're no longer stimulating any of these sphincters. It's just flowing freely out through the catheter and into the bag. When you plug it up, okay, now you're allowing this bladder to fill. And that filling is what's going to go back and re-stimulate the sphincters, stretch the walls again. That's how you train the bladder. You get it used to being filled up again, letting those muscles relax and contract. And but you want to do that before you take them off of it because, again, this is something that we have to work on. This is like a muscle where, you use it or lose it. And if you don't use it, you'll lose it. You'll lose the ability to control it. Also why, as we get older, especially women have a problem with this, you sneeze, you cough, and you're leaking urine, right? It's all about strengthening the muscle of that sphincter. So, and that's why you do like Kegel exercises, or you try to train your bladder by working this muscle out so that you have better control over it. Make sense? Any questions on the basic anatomy of this here? Oh, I did forget to mention that. So you got the two ureters coming in to the bladder here, and then you have one urethra leaving the bladder. I know it really bothers me. Y'all cannot pass this class if you don't know the difference between a ureter and a urethra. We're not even talking about spelling, okay? Because I saw some atrocious spelling of ureter and urethra on the test. So I'm just talking about in general, please understand the difference between the two, okay? All right, so micturition is actually peeing. What is the act of releasing this urine from your body? What happens with micturition? It is voluntary and involuntary. And we kind of already talked about this. Filling up of that bladder with urine is going to initiate a response from your stretch receptors, goes to a spinal reflex in your spinal cord, and then that's going to go back, release the internal sphincter, and then you have to train your external sphincter to be strong enough to hold it until you voluntarily release it. Then the urethra is going to, urethra is going to carry urine from the bladder to the outside of the body. In males, that same urethra is where semen comes out. So we're going to talk about the difference between the male and female anatomy on this next slide, I believe. Yep. All right, so let's take a look at this. So over here on the male, you have the bladders right here, okay? Look at this urethra. It leaves the bladder, goes through the prostate. That's the prostatic portion of your urethra. And then it's going to travel through the penis until it leaves the body. Notice that over here by the prostate, this is where semen is also joining that urethra. So you have one orifice that serves two functions, urine and semen. Also notice how long this urethra is. It is pretty long in the male, okay? So we have three parts to the urethra, by the way. The prostatic urethra is the portion that's within the prostate gland. The intermediate is that little tiny connection here, and then you've got your penile urethra, or spongy urethra because it's in the corpus spongiosum that travels through the penis. It's a very long urethra, right? Now look at the female. Females basically have a bladder and then a very short urethra. Notice that the reproductive organs are behind all of that, so they're completely separate. They're not using the same thing for anything, okay? So with the female urethra, because it's short and because of the location, it has a very high likelihood to allow bacteria to migrate up the urethra. And that's why women are more prone to urinary tract infections than men are. Notice the distance here. Bacteria has to travel quite a bit before it can get to somewhere that it can cause any type of damage. Whereas here, we don't have much to go, right? Very easy to get up in there and be all happy in the bladder and start pollinating. And then over here we have a little, in the square, it tells you that the male urethra is 5 times longer than the female urethra, and that there's 3 segments to the male urethras and only 1 short segment in the female, and that in males, the urethra is the common duct for urinary and reproductive systems. In the females, it is completely separate. Yes? Okay, so let's talk about that. First, I need to know that you understand that the uterus, which is what produces the menstrual bleeding, is going to connect with the vagina, and that's where the blood comes from, right? And the bladder is completely separate, and the urethra. So the question is, well, what about if you have a patient that is during a menstrual cycle actively bleeding? Is it okay to have blood in urine, right? No. And you have to train your patient or instruct your patient on how to collect a urine sample without having any blood interfere. There's a process of cleaning. There's also a process of catching urine midstream. So you allow some of the urine to flush first, and then you catch the middle part, and then you finish it off. So you do try during collection times to make sure that you don't get any, but that would be like a user error, if that makes sense. And that is something you have to note in your notes so that whoever's examining the urinalysis will know that this is a possibility. Okay, So let's talk about some of the disorders of the renal system. And I pared it down really just to the ones that you really need to know. Renal calculi, those are kidney stones. We've all heard of them before, right? You've kind of wondered how they happen, okay? And I always associate it with like the science project that you may or may not have done in like kindergarten, where you mix like salt and water or sugar and water, then you put a string in there and you leave it for a few days. And when the water sits there, those crystals will actually granulate on top of that rope and give you like rock crystals or sugar crystals. Anyone ever do that? No? You guys have missed out on your childhood. Okay, if you've never done that, if you ever go to like Disney World and you go to the candy store where everything looks amazing and they have those like sticks of crystals, that's how they make them. That is it. The idea is whenever you have something suspended, when you mix that sugar and water, the sugar molecules are suspended in the water, right? But if it stops moving, when you have a stagnant fluid, those crystals are likely to form because the sugar molecules are much heavier than the water, and they will eventually settle somewhere, whether they attach to that stick or to that rope, or they sink down to the bottom. So that's kind of what happens with our stones in the kidney. You'll have granules that form in the pelvis. Most of the time it's in the pelvis. It doesn't have to be in the pelvis. It really is just looking for an open space where it can be stagnant for a little bit. That's all it takes. And then a lot of times you'll see it in patients that have repeated urinary tract infections. Again, if you have an infection, you have inflammation, you may have some pus, you have places where urine can, rather than flow freely, may be stagnant or may be stuck. You could have an enlarged prostate, again, blocking the opening to the urethra, causing stagnation. There could be pH imbalances, which will cause those minerals to granulize. Or there could be an excessive calcium in diet, more than you need. So you're trying to excrete a lot of calcium. So it's like having hard urine, right? Just like hard water stains on your faucet, you could have a high mineral content to urine that allows stones to form easily. Do you not have something to take, Robert? I'm worried about you. Are you sure? He's in agonizing pain back there. Okay. So these are all causes of kidney stones. There are other causes also. You could have a polycystic kidney or a large cyst. Anything that gives you somewhere where it can stagnate for a little bit gives you a liability for stones. And they are super painful. You never want to have one in your life, I promise you, ever. They are the most painful thing ever. They're worse than childbirth. Yeah. Do you get them? Yeah, they're really painful. I feel for you. Like, I am not an emotional person, and I hardly ever sympathize with, like, I'm not empathetic at all. I'm bad. But that's what makes me so good at what I do, because I have no empathy. But kidney stones are the one thing that I know, like, oh my God, they're dying right now. Like, I can feel it. I like when I work, like, or when I used to work, I'd be like in the maternity ward, and, you know, I had no sympathy. I'm like, shut up. I'm thinking in my head, like, if you just stop screaming, it'll be fine. But when it comes to kidney stones, I'm like, oh man, give him morphine. Give him something. Let's give him something quick. Okay, so UTIs are urinary tract infections. Very common, especially in females because of the short urethra. Different stages of urinary tract infections. It can be just urethritis, which if you knew where the urethra was or what it is, you would know what urethritis is. It's infection of the urethra. It may travel up even further and become cystitis, in which the infection reaches the bladder, or even further than that. It can go up the ureter to the kidneys, and then you're in pyelonephritis, which is an infection of kidneys. Not good. You don't want to get at that stage. Okay. Do what? IC? I don't know what IC is. Oh, yes, same thing. Cystitis. But it might not be, it doesn't have to be bacterial. We're talking UTIs as in bacterial. Most of the time it's bacterial, but it can't, like interstitial cystitis can be viral. It doesn't have to be bacterial. Okay, and then the last thing is our renal failure. So this is when the kidneys are no longer able to do their job. It may be one kidney, maybe both kidneys, but bottom line, they can't take that filtrate out. They're not producing urine the way they're supposed to. you end up with those waste products and metabolites still in the blood, and that's when you have to intervene with something like dialysis, in which you hook a patient up to a machine, and the machine acts as a filter for their blood rather than their actual kidneys. So the machine goes in, takes blood, filters it, and then returns the blood. So it's like having an external kidney. And some common causes of renal failure are things like untreated sugars, diabetes. Diabetes is one of the causes. Prolonged hypertension that's untreated. If you can't control hypertension, eventually those kidneys are exhausted. You can't do it. And then there are some inherited conditions that also can lead to kidney failure. Bottom line, you've got high levels of urea. That is one of the waste products that the kidney excretes, and that's actually what gives urine its yellow color and the smell. And then you'll have those other waste products in blood. Oh, questions? Oh, all right. There's your summary of homeostasis and the urinary system. You guys can look through that if you want. And we are going to now go to fluid and electrolyte balance.